Okay, let's continue now. So I was talking about the external walls, the girthing. I said that for the walls, I shall not go back because already that is something that we went through, and it is similar. It is all similar. So I'll definitely just go straight. Now, I said that for the length of these walls, I'd already mentioned that the length of the external walls will be obtained by girthing, and the height will be taken up to some convenient level. For example, this is very key. You may decide to take your height up to the eaves level, which I know your construction technology must have told you about that, or it depends. It may be a retaining wall where you take it up to the topmost height, but more still, it could be, say, a certain recommended height of the wall. So any additional areas, for example, the gables, the parapets, these will then be taken off. I hope the gables and parapets, all this is your construction technology, but in case you don't know, you'll ask me, I'll explain. So you measure the whole wall area, and this time when you are measuring, people make a mistake. They normally ask the same questions. The doors and the windows and any other openings are assumed not to be there. Let me use that term. So when you are handling the walls, you take it as though it is fully a wall. As you'll see in the notes that will follow, things to do with the windows and doors, those are deductions that come in later. And when you are deducting, I'll ask you, of course I'll mention about it. For example, if you come to the level for doors, taking off doors, you describe the door and you include an item and deduct the area of the walling it occupies. That is how we do it. So the first case, you take the entire building as though it is all closed. And then when you come to the level for taking off for windows and the other openings, each of these you deduct, you make deductions equivalent to what you've taken off. And the one who is going to do the abstracting will definitely follow suit. He will know how to do it. So, incidental labors, for example, incidental means those labors that come in, for example, rough cuttings, eaves fillings, and so on, will then be catered for after. Okay? Then after you are done with the external walls, you go to the internal walls. Here the measurement follows a similar incidence of the external, but you must carefully check on the type and thickness of each partition. I said check. Now, this we normally trick in the exam. You do the needful, and then you trick these people. You tell them the internal wall is going to be 150 millimeters. Now, because for them, they are considering the wall which is 230, they will think that the walling all through is 230. Yet it is not the case. So you must carefully check the type and thickness of each partition. Where there are a number of different types of partition, for example, you find a case where one wall is 150 millimeter, but there is another wall that is again same thickness as the external wall. But again, there is another wall, probably that is again thicker. So that's why I'm saying where there is a number of different types of partition, it is often helpful to color. You color. Of course, when we do the practical, what you do, you may use, I normally use a highlighter. For example, if I've used the pink on each wall that I take off, each wall that I take off, I highlight that wall throughout. Then when I'm handling the internal wall, I still highlight them as they appear. So where there are a number of different types of partition, it is often helpful to color each type in a different color on the plan. Internal walls are also measured in square meters, stating all essential particulars as we described before. You measure them in square meters too, and then you mention the particulars. Okay. That drives me to the second item above the substructure, and that is the roof. So that you'll discover that after I've done the roof, that means the shell is covered. Now, roofs are of two types. Namely, we have the pitched roof and we have the flat roof. This is all covered in your construction technology. Now, both types can be subdivided into two main sections for purposes of measurements. One, when we are measuring, we look at the construction, how it is constructed. And two, we look at the coverings. So the order of measurements of these sections will vary in practice, but on balance, it is probably better to take the construction first. So you look at the truss construction, and then later you bring in the coverings. So let me begin with the pitched roof. And on this note, I'll ask you to look at the different kinds of constructions that are with you in your construction technology. Look at them and see how they are handled. And this is going to help you follow the visual, especially those of you who are not normally on construction sites. So the order should follow a logical sequence. You very well know when we are at the site, we begin with wall plates. The construction begins with the wall plates. So this is why I'm saying that we should follow the sequence as it appears. Okay? So the wall plate comes in first. And then after the wall plate, I hope somebody knows what the wall plate is all about. After the wall plate is done, then next they will begin to lay the trusses in the sequence as they come up. To those of you who have not been exposed to these constructions, I will try to bring in a chip. Don't fear to ask, please. Where you feel I need to show something, you let me know. Otherwise, I may assume when actually you are not there. So in case I happen to show something, to mention something, at the moment I give you opportunity to ask me, please do ask me. Don't wait to post in an email. Sometimes I may not look at your email, or I may still be very busy and I may just look at it and probably not even get bothered to follow it up. So it is better when you have a question to always ask it as it comes here. It helps you, and also you inquire from colleagues. So now I'm talking about the roof, which I very well know that it is not very common to some people. Yes, I'm looking for some illustration here. If I come across it as we go on, I'll bring it on your screen to help somebody understand what we are talking about. But meanwhile, let's go with the notes. So I said you consider, first of all, you look at the plates. Then we assume that after the plates, the wall plates have come on. The wall plates are normally the timber that is laid across the wall. These support the trusses, the roof truss. That's what we call the wall plate. So when the wall plates are done, we then consider the rafters. After the rafters, we shall consider the ceiling joists. If we have collars, like we shall see in this example, there may be collars, we shall put it there. And then after you've constructed the entire truss, then what follows is the purlins. But before the purlins, of course, the struts will come in, the ties will come in, the ridge boards will come in. Then you put the purlin, the hips and valley rafters. So after you've done all this, that is when you can go ahead and let's visualize it in detail. The timber work now. So if you are looking at the timber work for the roof truss itself, the roof timber, we shall be considering the rafters, the ceiling joists, the purlins, the struts, the fascia boards, and so on. All these, as long as it is a timber roof truss, we shall measure it in meters, linear meters. I hope that one you've taken it at the back of your head. So you state it, you enter it as a linear meter, and then you state the size. The size of these members are indicated in the description. The thickness, beginning with the thickness and the width, which we are going to see. Then the kind and quality of timber that you are using. Sometimes it may be sawn timber, it may be which kind, at the site. So you state which timber. Is it Nkarati, Muvule, what, pine? So you must state in the description. The other day I said these descriptions are used by somebody who's bidding. Because if you don't tell him and he just assumes, he's likely to give you an expensive quotation or a cheap quotation. Then you also state the kind and quality of timber and then the preliminary treatment of timber. For example, some of the timber is pressure impregnated. So the quantity of timber required will then be calculated by the following formula. For example, quote me very well. This is why I'm putting the example. Sometimes we may get the length, that's the length of the building. You are talking of trusses now. You get the length of the building, you divide it by the given spacing. Say if the spacing of the trusses is 2 meters and the length is say 20 meters. So you'll get the 20 meters divided by the 2 meters, which gives you 10. Okay, 10 trusses. Those now will be, will be spacings, 10 spacings, and then you add 1. This is now mathematics. So that will give you the number of trusses that you need. If the length is 18 meters and the spacings, yes, this is what I've explained. So the number of trusses can be gotten this way. Well, sorry. If we have a length of 18 meters and the spacing of rafters is 1.5 meters, then the number of trusses will be calculated in the following three ways. If the roof is hipped end, then you get that length, you divide by the spacing, you subtract 1. That is the hipped end. If it is a gable end, then you get the length, you divide by the spacing, you add 1. That's for the gable-ended. Gable-ended, I mean, if the walling is visible up to the tip of the roof, that is called the gabled. The gabled end is visible. Now, if one end is hipped and the other is gabled, then you don't add, neither do you subtract. You just get the division, and that is all. So this one goes to you. I will give one example, which is majorly hipped, and that is what we shall go for. But assuming in the examiner tricked you, because that is the work of the examiner. The examiner may trick you and do the other, brings a different truss, different from what you know. So don't you say, we've never studied this. It will be upon you to look at it, reason it out, and then continue. Okay? So, now, where the roof section, I'm talking about the length of rafters now, where the roof sections are drawn to scale, and you are very sure that these things were drawn to scale, the easiest method is to scale off. The easiest method is to scale off. But I'm saying that if you are sure of the scale, that is when you scale off from the drawing. Otherwise, you'll use the variable mathematical calculations. How? We can calculate the length by multiplying the natural secant of the angle of pitch by half the total span of the roof. This goes to the usual calculation of triangles, trigonometry, and others may come in. Coverings. Roof coverings are of various types. For example, you'll find coverings in slates, coverings in tiles, coverings in corrugated or draft sheets. But still, in our villages, you all know we use thatch roofing, and at times we can use bitumen covering, say, a cast reinforced concrete roof slab. Now, whichever you are dealing with, the following are key to note. Let's look at the slates or tiles. The standard method of measure is in K2 up to K15. And the law or the code will tell you that you should state particulars of the following. It should tell us the kind of tiles, their size or slates, their type, and the quality of slates or tiles. That is why you will see in the bills, they will tell you Uganda Clays Kajansi tiles. So he has stated, and then he'll give us the type, that is the type now, and then the kind. The kinds are many. Of course, you may find that in the examples that we shall give, we shall be stating which type that we use. So I'll give you time to look at the catalog. For example, Uganda Clays has given a good catalog that we follow. And if you are following tiles, for example, in Uganda here, quotations prefer Uganda Clay's Kajansi standard. So then you look at the extent of the lap. Then what I mean, each of these tiles will lie over the other. So how it lies over the other, that is why I'm talking about the overlap, the extent of the lap. Then the method of fixing and the number of nails or pegs per slate. Sometimes we may require nails, sometimes we may just place them on buttons. And then you shall also state the size and the type of lathe or buttons. And I hope these are all very clear and vivid in your minds. Then how do we go about the measurement of slates or tile roofing? Roof coverings shall be measured in square meters. Square cuttings around openings, raking cuttings, curved cuttings, valleys, hips and vertical angles, all these shall be given in linear meters separately. So I'm going slow on this because the other day a gentleman told me I was fast, but I'm going slow on this. Then the measurement of roofs. When you talk about roofs, corrugated or trough sheets, the second example, corrugated or trough sheets, the SMM is K16 to K26. Here, particulars of the following are given: the kind of sheeting, the quality and gauge of sheeting and the type, extent of side and end laps, nature and general spacing of the structural supports, for example, purlins, and then the method of fixing the sheeting. So roof coverings in this standard shall be measured in square meters. So how do we measure corrugated or trough sheets or corrugated iron sheets and so forth? Square cutting around openings, raking cuttings, curved cuttings, valleys, hips and vertical angles shall be given in linear meters. You must have seen roofs where you find it is common in Britain and other temperate countries, where instead of showing a level, say a storied level, they'll just put some window protruding within. So when it comes to such work also, it is catered for how you deal with it in the SMM. It is not common in Uganda here, of course, because we are in the hot environment. You may not sleep in such regions. Okay, so now let me consider too the flat roof covering. Flat roof covering. One, we shall look at flat roof covering, the asphalt. Because sometimes you may use asphalt or you may use bitumen and other materials. Now, if we are using asphalt, the SMM section J will cover that. If we are using bitumen, SMM K36 will cover that. And at this point, I think people have made their homework to get the SMM for East Africa. So the main areas of asphalt are measured in square meters. and we state the thickness and the number of coats of asphalt that we will lay. Then the underlay of felt, cork, fiberboards of similar materials, and any other reinforcement must be included. So that is how we deal with asphalt. Now, when we are talking about bitumen, the unit of measure is the square meter, and it is classified by slope. We look at the slope. Then you will give full particulars of the felt. For example, the extent of the laps, the nature of the base, and the method of securing felt to it, and the nature of surface treatment. So these are very, very key when you are dealing with the bitumen. Then I'll definitely go to the roof calculation. But maybe before I get there, I must request that we shall go to the plan that we used earlier, and that is what we shall definitely consider in our case here, in our calculation. And up to this level, I hope somebody is following me, and I would love to hear from you participants to know if I'm with you. So up to that level, are we still together?
Yes, we are together.
Together.
Yes, engineer.
We are together. Can I receive, okay, I have some little time because I have another meeting to get into, but I'll try to just give you the plan that we shall consider, and then next week we shall get into the calculation. If you can look at your plan, the one that we handled the other day, we assume it has been raised up to this level, and that is how the roof will look like. Now all this work will be done by the architect, okay? Will be done by the architect, and then he will present you the section also. He will present to you the section also. So that is the section, and in this section he is saying that if I take you back, oh sorry, I'll have to mute somebody. Okay, so when you look at our plan that we looked at the other day, or that we considered, you find that the middle part, the middle arm, the external wall was making a certain figure. Let me take you back a little to that, if I can capture. Yes. Now you remember we had this making 4, and the 4 was setting center to center, okay? Now if it is center to center, that 4 meters, okay? And you subtract the extremes of the walls, which are 230, you'll definitely get 3.77 as the internal dimension. So this is why when I came to my section, assuming I'm taking that section on the extreme here. The section shows it will be 3.77. You can try it during your free time. So the walls are 230 and the section internally is 3.77, and we've allowed it the eave, the protrusion of the roof to go 0.425. And when you look at that measure, we are giving it fascia boards and badge boards, and these are 25 millimeters thick, okay? And then we are giving it a tilting fillet. A tilting fillet is normally given at the edge. It is 75 by 75 millimeters. And then I'm describing this for somebody. Now, when you look at that X here, the 100 by 75 is the wall plate. That one is laid across the wall. And then it is on that where the truss now will be the members that I'm describing. One, they are saying we have tie beams, but there are two of them. Two tie beams, 150 millimeters by 50. And we have the rafters, they are also 150 by 50, but this is a single one, okay, for that case. And then we have a ridge board, that a ridge piece at the topmost where the rafters meet. Where they meet, we have it there stated, and then the angle of pitch, the angle of this truss is 45 degrees. Now the members that join in between, we have the collar beam, and then we have struts and ties. The collar beam is 150 and there are two. I hope you can see that cross member above the tie beam. And then there are also struts and ties 100 by 50 each. Now you as the taker off must look at the notes. The construction notes, they have said they are using interlocking tiles, and these are 340 millimeters by 230 millimeters, okay? And they are telling us they shall also lay a polythene sheet. Those who have been at the site, you know, we put a polythene sheet, and then we also put chicken wire mesh, and then we put the buttons. The buttons are 50 by 40 millimeters, and the trusses are spaced at 2.4 meter centers. All timber is treated pine. So once they have omitted some members, you look at the scale. This one, they say the scale is 1 to 25. So in case there is any omission that you want to get, I said you may just scale off. Like you will see sometimes calculations will give you either smaller values or larger values. So where you find very small members, you may have to scale off the drawing. So that said, now we may have to get into calculations straight away. But for today, I said I'll do the calculations next week. And I want now to open up for any question up to where I've stated. And then I'll answer those questions.
Excuse me, sir.
Yes, you are